it's either car or cat, and then we'll add an exclamation mark at the end. All right, so now let's run the application again. And here I'll type in the number 1, you want car. See how that formatted it nicely? And we'll run it again. And this time we'll type in the number 4, you want a cat. Okay. All right. So we learned quite a bit in this lesson, just tacking on some additional features of Visual Basic. We looked at, most importantly, the if, and else if, and else, and end if statements in order to add some conditional logic to our applications. So we made some decisions, and based on values and evaluating the truthiness or falsiness of a particular expression, we're going to execute one of the code blocks inside of our if, else, end if code block. All right. We also looked at this magical IIF method, which allows us to, again, evaluate true or false, and then return either a true or a false value that we can then like assign to a variable in this case. Then we also talked about how to add multiple items into input parameters using commas to separate each of the values in the input parameter. And then finally, we talked about this replacement syntax with curly braces and with the number 0 inside of it, and how we're able to replace a part of the string that we're giving to WriteLine by using the replacement code and then passing it the value we want to be stuck into that template, okay, for display. All right, so you're doing great. We're learning a lot, and let's continue on. We're going to keep adding on the complexity and make our applications more and more interesting. See you in the next video. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, I want to spend a bit of time talking about some of the smaller syntax elements in Visual Basic that you'll need to master in order to understand how a properly formed line of code is constructed. So in one of the first lessons, I may have briefly referred to the Visual Basic syntax having nouns and verbs and punctuation. And I want to elaborate on that just a little bit more and explain what I meant by that in this lesson. So just like the English language has parts of speech and it has punctuation, the same thing is true in software development, and the Visual Basic programming language is no exception. So we're going to talk about those building blocks to create those sentences, those basic building blocks to create instructions in Visual Basic. And so statements are like sentences. Statements are complete thoughts in Visual Basic. They're like complete sentences. And a statement is made up of one or more expressions. And in turn, an expression is made up of operators and operands. All right, so it goes statements. Statements are made up of expressions, and expressions consist of operators and operands. So we've seen statements, obviously, they're just simply lines of code, executable instructions that we've given the compiler whenever we type them into our module1.vb. Expressions are, some examples of expressions are things like a method call. So console.WriteLine passing in an empty string or hello world, whatever the case might be. Whenever we use the if statement, we evaluated an expression to see whether it evaluated it true or false. So the expression portion of that was user value equals 1. So if user value equals 1, then execute this code block below it, okay? And then also there are expressions of assignment where we're assigning the value of a variable equal to some other value, okay? So each of those are examples of expressions, and they have two things in common. They are made up of operators and operands. So an operand is similar to a noun in a sentence. They're things that are nameable, okay? So variables, that would be a good example of an operand. But things like literal strings, that's an operand, or a literal number like the number 7, that would be an operand as well. And so these are easy to remember because you're creating these yourself. You're giving names to variables or even classes or objects as we get further along. And you're giving value to literal numbers and literal strings, right? So operators are similar to verbs. So you have operands are like nouns, operators are like verbs, and they will act on the nouns. So they're things like, for example, the addition operator or the equality or assignment operator or the string concatenation operator. Typically, you're going to use built-in operators, whereas operands, you name them yourselves. Typically, operators are provided by the programming language. Now, there's exceptions in both cases. You could create your own operators or overload operators. That's kind of an advanced topic, so this is a little bit loosey-goosey, I guess you could say. And there's quite a few built-in operators, and you're going to need to memorize many of them because it's how you're going to perform actions on your operands, the things that you come up with, the intent of your code. So fortunately, as you're getting started, you can use kind of a subset of all of the operators that are out there, and then learn them, commit them to memory over time, and not have to refer to a cheat sheet whenever you need to remember them. So to kind of help facilitate this, what I did was create a project offline called Operators, Expressions, Statements. And I merely created the code that you see here. And you don't have to type this in yourself. You can just open up this project if you want to follow along on your local computer, because I don't know that there's any real value to typing this in. This application doesn't really do anything. It's just illustrating code ideas. Okay. So if you run it, it's not, I don't even know if it'll do anything, honestly. I don't think it has any, yeah, it has a console write line at the end, but that's about it. Okay, so just want to walk through quickly. This is not an exhaustive list, but this will give you a few to chew on and to work with initially. We've covered some of these already. We'll add on a few during this lesson. And you can expand your vocabulary of operators and keywords and so forth over time. But in each of these cases, an expression is made up of an operand, like a literal string or a variable or an object, and an operator. So an operator is something like the assignment operator. So here we have an operand, which is x, and an operand, which is the literal value of 3. And the operator is acting on the value of x. So the way we would read this, the value of 3 is being assigned to x. All right. So you see the associativity of the code and the direction. It will go from right towards the left. So anything on the right will be evaluated first, and then it gets assigned to the value that's on the left. All right, so that's the assignment operator. We have the addition operator, the subtraction operator, the multiplication operator, the division operator. So these are things that you would probably come to expect. Then you can see we looked at the equality operator to see if two values are in fact equal or not, true or false, x equals y. Now there's some other variations on this. We can check, for example, if x is greater than y. Now in numeric terms, the greater than, the less than operator, the greater or equal to, and the less than or equal to operators, they're all pretty easy to understand, but you might be working with dates or strings, in which case the greater than, less than, greater than or equal to, less than or equal to might be a little harder to understand what is being compared. Is it the length of the string? Is it the whether they're alphabetical order or not, and so on. All right. Then there are conditional operators, the conditional or and the conditional and operator, so that you can tie two expressions together and evaluate them. So x is greater than y, a is greater than b. If either of these are true, so if this is true or this is true, then perform the code that you see in that code block. The AND operator is inclusive, so both have to be true in order for this to happen. So x must be greater than y and a must be greater than b in order for the code inside of the if statement to be to be executed. All right. We've also talked about the member access operator, the period, and how that allows us to call a particular method of an object or a class. In this case, we've been calling the WriteLine method of the console class by using the period in order to access it. Now, in this way, the associativity goes from left to right. So we start with the console object, and then we call into its WriteLine method, and then we pass in a input parameter of a literal string. And so in this case, also, I just want to point out that the double quotation marks, that is the literal string operator. And then there are other operators, like, for example, the as operator. Now you could say as is a keyword, dim is a keyword. That's all true. Sub is a keyword. Module is a keyword. But if it acts on operands, then it's also a operator. In this case, it acts on the operand of B, assigning it a data type of integer. All right, so why am I telling you all of this? Well, because the syntax rules of a programming language really do matter. So for example, I can't just do that and expect anything to happen. I mean, Visual Basic Compiler will look at that and say, what are you trying to do? You've only given me expression, and an expression, it's not a complete statement. I need more than just an expression in order to do something, okay? So in this case, we're only just doing x plus y, but x plus y what? All right, what do you want me to do with this? So in situations like these, you can see Visual Studio will actually catch these syntactical errors as compilation errors. We can't even run the application. We can't even compile this code into an executable that will run inside of the .NET Framework CLR, the .NET Framework runtime. Why not? Because the code cannot be compiled and turned into a language that is acceptable by the .NET Framework runtime. So in that case, you can see the code editor gives us this red squiggly line letting us know that we have a problem in our code, and so it anticipates the issues with the code by pre-compiling as we're typing. All right. If we were to hover our mouse cursor over it, we're going to get some very vague explanation as to the problem. Method arguments must be enclosed in parentheses. So it thinks that what we're trying to do is call some sort of method like this. Right? And even so, it's still going to have some issues. All right. So basically, we don't even have enough code here for Visual Basic to give us a good error message, unfortunately. And so essentially, we just have to be aware of the fact that when we type in a line of code, we have to kind of be purposeful and understand what it is we're trying to accomplish. If we don't have the right set of expressions filled with operator and operands, as we had here just a moment ago, then we're not creating a properly formed statement. Since we don't have a statement, it can't really do anything with that code that we write. So for beginners, all you really need to understand is that there's a proper syntax in Visual Basic, just like there are rules for the English language, just like there is proper grammar in the English language. So understanding that is a big step to solving your own problems whenever you're phrasing Visual Basic instructions that the Visual Basic compiler will accept and compile down into a language that the .NET Framework runtime can understand. So I tell you what, let's go ahead and stop right here. Let's recap the things that we talked about in this lesson. First of all, we said that statements are complete instructions in Visual Basic. They consist of expressions, and a statement is like a sentence in the English language. And expressions are things that contain nouns and verbs, the combination of the two. Okay, so actual expressions are made up of operands and operators, and an operand is a thing. It's like a variable or a literal string, something that we give value and importance to by naming it or giving it value. And so for now, you can think of, for example, the console class. That's an operand. and the variables that we've created, those are operands. Whereas operators, and we spent a lot of time looking at operators here, and there are even more than that that we didn't talk about. Like, I don't know if I said anything about the method invocation operators, but this is definitely an operator that will kick off the execution of a method, right? So there are lots of different types of operators, and you'll need to learn the operators in order to perform actions on the operands that you create, and that gives the instructions, the proper instructions to that formulate your program. Now, we've already been using these operators for all sorts of purposes until now. Even if we didn't identify them specifically as operators, we're still using them, and just understand that they are what actually do things in the application. And just by giving, for example, X, or giving console, by itself on its own line, it's not going to accomplish anything. We have to use operators. And we have to use operands. This is an operand, okay, in order to accomplish things in our applications. And that's all I wanted to say. All right, so hopefully that was helpful in diagnosing and understanding the code as you write it. All right, let's continue on the next lesson. We're doing great. See you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we're going to focus on iteration statements, and a specific iteration statement, the for next iteration statement. Now, sometimes you're just going to need to loop or iterate through a block of code. You're going to need to iterate through a sequence of items, and maybe to perform a series of checks until you find a successful match, maybe to execute the same code a number of times, just because that's part of your business rules, whatever the case might be. Actually, you'll find yourself doing this more than you might anticipate. And while it may not seem all that practically useful at first, trust me, you're going to need this in your toolbox as you start to write more interesting applications. So let's create a new project, and we're going to call this for next iterations, and click OK. And the syntax is really simple, and I'm willing to bet that you're able to figure out what this will do without me telling you what it does. So here we go. All right, there we go. That's all we need. So can you guess what you're going to see in the console window whenever we run the application? Let's see if you're right. Okay, so if you guessed that you would see the numbers 1 through 10 printed out into a console window, you're right. All right, so basically all we're doing is executing the block of code defined by the for and the next statements, in this case in lines 5 and 7. Anything between the for and the next will get executed a number of times until we've reached a certain condition. In this case, we're going to start off with the value 1 and assign 1 to index. But once we get to assigning the number 10 to index, that'll be the last time we iterate through the code defined inside of the code block between the for and the next. And then we break out. And here we, in line number 9, we wait for the end user to respond that they have actually seen the content that we printed to screen, and that's pretty much all there is to it. So we're instructing Visual Basic to execute a block of code a number of times, and once we've completed that sequence of times as defined by this higher end boundary, then we'll break out of the for next loop iteration statement and move on to the rest of our code. All right. So inside of here, we can do some interesting things. So like, for example, what if I were to go if index equals 7, I could do something like then console.writeLine, found 7, like so, and we could run this. And then once we get to the number 7, we can print that out. I have an idea. Why don't we shorten this just a little bit? Like before, I don't think I showed you the then portion of the if, else statement, but you can use the then in order to combine everything on a single line like so. All right, so the then will allow you to combine a simple check with a result. If index equals 7 is true, then go ahead and perform this line of code. So we're able to condense 3 lines of code and do 1 line of code. And now when we run it, we get the exact same results. Okay, I just wanted to show you that little use of the then keyword. Great. And what if, though, let's comment that out. What if, and let's bust back over here to if index equals 7, console.writeLine found 7. And now at this point we found what we were looking for. What if we wanted to break out of this loop? We're no longer searching for the value. We found what we were looking for. We could do something like exit 4. Okay, and so now when we run the application, the result looks a little bit different. We get to 7, we found 7, and now we exit out of the for statement and we continue on executing our lines of code. Great. This might be a good time to talk about one of the features of Visual Studio. And again, I'm trying not to talk about Visual Studio, but you still need some tools in your toolbox if we're going to build applications. And one of those tools are the debugging tools of Visual Studio, which is probably one of the best reasons to use Visual Studio. You can actually pause and watch the execution of each line of code by simply setting a stop sign or a breakpoint in your code. And then when we execute the code and we get to that breakpoint, then we can continue to step through the code line by line or continue on and allow it to continue to execute the lines of code. So to set a breakpoint, it's really easy in Visual Studio. There's actually a number of different ways to do it, but I find that the easiest way is to find this little gray column off to the left-hand side underneath the tab heading and just click in that column for the line of code that you want to set a breakpoint on. So in this case, I want to set a breakpoint on line number 6, so I just click in the little gray area next to 6, and it creates this little stop sign over here on the left. I guess it's a circle. It looks more like an octagon to me. And then it highlights the rest of that row in red. And so now whenever we go to run the application and we're in debug time, we're actually, the execution of the application has stopped. Now, unfortunately, I got this little window that popped up and I gotta get rid of that. Move it down, but you can see that in this case the line of execution has stopped here on line number 6. And what we can do is hover our mouse cursor over the variables. In this case there's only one variable, but if I hovered over in this case the variable index, we can see its current value, and I can click what was formerly the start button. It's now the continue button, and when I run it and hover my mouse cursor over, you can see that index has increased to 2. So when I clicked continue, it executed the next several lines of code, came back up to the top, and we were able to break again on that same line of code since we're just iterating through the same block. Now I can use keyboard shortcuts, or I can use these little items here in the toolbar while we're in debug mode to step through our code. Now I'm going to ignore the step into and the step out of. They're kind of special cases and not really essential to us until we start building more complex applications. But the step over is probably what we want to use. So I'm just going to hit this step over or F10 button on my keyboard. And here I can just begin to step through each single line of code. And I can continue to evaluate what the values are. I can look at this autos window or the locals window, or even the watch window, and see the value of variables. So in this case, index is one of the local variables, and I can see it here, its name and its value. And as it changes value, notice that as we executed that for loop in line number 5, the value turned from a black font to a red font, indicating that the previous line of code changed the value of that variable. All right, so that's just a little visual cue to let us know that something just changed in our application. Let's see what else we can do here. If I have a specific variable that I want to keep an eye on, I can kind of highlight it and then drag and drop it into a watch window, so that even if I am moved off to another part of the program, I can always keep an eye on the current value of the index in one of the watch windows. All right. So the other thing that you can do, which is kind of neat, is hover your mouse cursor over and see the current value of any given variable. And I can even pin this down. So notice that when I did that, it create this little pinned area, and I can actually drag it and move it around so that as I start stepping through the code, that little window pops up here. And you might have seen it briefly change color to red whenever we hit the index 6. And I'm going to continue moving on through our code here. And at this point, we'll see that index will in fact equal 7. So we'll step into our if code block, execute the console.write line, and then we'll see what happens when we hit the exit 4. It jumped from line number 10 all the way to line number 14. And if we hit continue now, we'll just see this console window, and we're back in runtime, and I can hit the enter key on the keyboard to continue. All right, so those are just a really, really quick overview of the features. There is one cool feature that I want to show you that's applicable here since we're working with iteration statements, and that is we can configure our breakpoint by clicking the little gear wheel that appears as we hover our mouse cursor over our breakpoint. And I can say that I only want to break on this line under certain conditions. And the condition that I want to break on is whenever index equals 7. So whenever we hit that point, I'm going to say, let the breakpoint stop the execution of the code. Otherwise, let's just go ahead and blow our way through 1 through 6. And so now I hit the continue button. Let's hover our mouse cursor over our index, or we can just see it off here to the right-hand side. It is, in fact, 7. I'm done with that now. I could say I want to keep an eye on this and just keep that around, or I can actually just get rid of the whole thing by just clicking the little X button there. All right, but you see how I was able to configure this breakpoint and make it conditional so that it only stops whenever the index value is equal to 7. And there's some other options here that I could choose. For example, I could log a message when we hit a certain situation and then continue the execution. We're not going to do any of that right now, but notice this little tab, breakpoint settings, pops up inline. Very, very neat. And we can continue on. The last thing that I want to show you, and you can see that the icon has changed from just a red, I guess it's a circle, but it looks kind of to me like an octagon. But notice that whenever I change some of the settings, it has a white plus symbol in the middle of it. Let's go ahead and turn off that. But what I do want to do, say I want to disable the breakpoint temporarily because it's not useful to me at the moment. So let me just run the application. The breakpoint is still there, but we're ignoring it for this run of our application, and then I can enable it one more time or get rid of it altogether by clicking on it a second time. And any of the things that I did here, I'd be able to also do from the debug window, where I'm able to toggle breakpoints, create new breakpoints, even make them functional breakpoints, changing their settings about when they should actually be enacted, delete or disable the breakpoints, and so on. Okay, so let's go ahead and get rid of that, save that. All right, so I also wanted to show you something cool. Another feature of Visual Studio, since we're on this topic and we've got some time. I'm going to go ahead and, well, we'll just leave everything where it's at. Here, what I want to do is show you how to use code snippets. And if you can't remember how to use an if statement or how to use a for statement or any of the other things that we're going to learn about, typically what you can do is just type the first word. Even if you don't remember the exact syntax, you can type in for, tab, and bam, it expands it out and creates a code snippet, I can continue to tab my way through and notice that there are 3 fields that I'm tabbing between, and they're all kind of in this goldenrod or yellow color. And this will allow me to change, for example, the variable name that's used as the iterator variable. So I can change it from index just to the letter I. I can change it from 1 to, let's say, we'll start at the number 3 and we'll go to the number 13 instead. And when I've finished replacing